Hi everybody, this is going to be our note for 1.4, Exploring Transformations of Quadratic Functions. So to understand this lesson, we have to look back a little bit of what we already know. So we do know about quadratic functions. We have a graph here of y equals x squared. Sorry, I should put this as a function, I guess, of x squared. So we call this a parent function, or like the most basic type of function for a quadratic equation anyway. So this is the most simplest quadratic equation we could graph. So when we mean transformations just mean changes. So changes at the most kind of very basic level. It's changes of this quadratic function. So what kind of changes do we mean? Well, we're going to explore the graph more in 1.5, but just as a quick thing here, if this is my most basic one, where we just have like the vertex happening at the origin here. Well, speaking of vertex, we did learn about an equation that tells us about where the vertex is. So we learned about this vertex form equation right here. And we called it the vertex form because one, it tells us where that vertex is. And again, what is a vertex? Well, it's just like the highest or the lowest point. In this case, it's the highest point, or the lowest point of a parabola. And we know it's the vertex because of these two values. This is h and k, where this represents like a coordinate, like x, y, where the x value is the h part of the vertex form equation, and the k value is the y value is the k, which is from the k value from this vertex form equation. So if I know the vertex form equation, I know where the vertex is. But these letters actually tell us a bit more than just the vertex. They also tell us how we can graph this quadratic equation based on what this parent function is, what this most basic function is. So first we're going to learn about like terminology, and we're going to learn about what the letters represent, and then 1.5 we're actually going to get into the actual graphing part. So let's take a look at the letters. So I just realized I have a heater on in the background, so I just turned it off because it was making some noise before, so I apologize for that. So let's get to some of the letters. So we do have in our vertex form A, H, and K. And remember the X here, this is just some random coordinate on the parabola, and the X value here also has a corresponding Y value, or output from the function, and that would be, these could just be any points on the parabola. But we have A, H, and K, which tell us different things. So I'm going to start with what I think is the easiest one, and I'm going to start with the letter K. So as the value of K increases, we notice, I'm just going to tell you, the graph translates vertically up. And how much does it go up by? Well, it goes up by K units. As the value of K decreases, K becomes negative, we notice. The graph translates vertically down, and the same K units. When the value of K is 0, we notice the parabola stays on the x-axis. So if you need to copy this down, just pause the video, but I'm going to explain what's happening in each of these. So if we have our parent function, remember what he said before, and this is kind of a quick summary of what these letters do. I just have a graph here. I have my parabola like this. Well, when K increases, we notice the graph translates vertically up. And what we mean by when K increases, if K is a positive value, when k is positive, our graph translates vertically up k units. What do I mean translate? Another word for translates is shift. Translate is the most, is the proper term, I guess, but shift is also okay. They mean the same thing. So if we have a positive k value, let's say like positive 2, so if k is positive 2, well, my graph will be shifted up 2 units. So it's going to be like this. And if k is a negative number, k becomes negative, for example, like -3, we are going to notice that the graph, if it starts here, is going to be shifted down 3. So this is down 3. So the k value tells us how our graph is going to move upwards or move downwards. Now, if k is 0, meaning that there is no k value, and we saw that before in our last lesson, well, then the parabola will stay right on the x-axis, so like right on the origin here. So if k is 0, then it's just going to stay right on the x-axis. So this is how the k value can affect our graph. So we learned a couple new terms: translates, which also means shift, or just moves. It moves the graph vertically. Vertically means, I'm going to put this down here, vertical means up or down. So it translates the graph up or down this many units. If it was k was 2, like up or down 2 units, or down 3 units. That's what the k value does. All right, the next easiest one I think is, in terms of letters, would be the h value. So I'm just going to label this k first. This is our graph for what the k value is. We're going to make a graph for h as well. So the role of h. As we increase the value of h, or if h becomes more positive, we notice we're going to have another shift or translation in our graph. So if the k value was moving up or down, and notice when like the k was positive, positive goes up, like in the positive direction. When k was negative, it went downwards, and then in the negative direction. If k is up and down, we can kind of guess that h is going to be horizontal or left or right. So I'm actually going to write that. Horizontal. This means this or this. So left or right. So rule of h. So as we increase the h value, or if h is more positive, then you can also guess on the graph, on the positive direction, we're going to move our graph to the right. So as we increase the value of h, we notice, I'm going to try and write nicer this time, the graph translates, and you can write shifts if you want to as well. I'll put that down here again. The graph translates or shifts horizontally we're going to say h units, because we don't know what the number is in this case. So h units, and since we're saying this way, it's going to be to the right. See that t there? There we go. And then if h is a negative value, well, we're going to expect it to go in the negative direction, which would be to the left. So we can say graph translates horizontally, h, again, just some number we don't know, units, and since it's negative, we're going to move to the left. And when the value of h is 0, we notice the parabola stays on the y-axis this time. So what do we mean by that? Well, let's take a look and make a graph down here. So now we're looking at our h value. So if this is our parent function, our basic graph, and again, we're going to look at this more in detail later. We're going to actually get actual coordinates for our parent function. But our h value, if h is positive, is just going to shift or translate our graph horizontally h units to the right. So if we said it was like plus 4, we're going to move to the right 4 units. So all of our points, including the vertex, would move over 1, 2, 3, 4, and we'd have the parabola shift this way. And if we had a negative number, let's say like minus 3, well then our graph would shift 1, 2, 3, and it would shift to the left 3 times. So we can say here this is like minus 3, this is plus 4. And if the parabola, or h, is 0, well then there is no moving back and forth, so it's got to be on the y-axis. So it's got to be right there. So it could still move up and down, but it's still going to be on the y-axis if there's no, if h is equal to 0. So that's how the h value affects our graph. It kind of shifts it to the left or to the right. So our last letter to look at is the letter A. Now the letter A is a bit different because it's a bit more, well, it has bigger kind of changes. If we look at h and k, if we look at the operations between them, this is plus, this is minus, and the plus and minus just really mean we're shifting left to right, or up or down. But the A value is A next to this bracket, so the A implies we're doing multiplication. So we're going to be doing see some different kind of changes as opposed to just moving back and forth or up or down. So the role of A. As the value increases where A is greater than 1, we notice, first off, greater than 1 means we have a positive value. So when we have a positive value, it means the graph is going to open upwards. The parabola opens up, and because we have a number greater than 1, we have something called a vertical stretch by a factor A, and whatever the A value is, that's going to be our factor. So when A is positive and greater than 1, our parabola opens up, and we have vertical stretch by a factor of A. When the A value decreases, it's less than negative 1, so negative 2, negative 3, negative 4. The negative means our parabola is going to open down. So what do I mean by up and down? Well, up is when the opening of the parabola is facing upwards, and downwards means the opening goes downwards. So the parabola will open down, but because we still have a number that's like negative 2, negative 3, negative 4, those are still whole numbers, we're still going to get a vertical stretch. But it's just going to be in the downwards direction. So just think the sign, the positive or negative, just tells us if it moves up or if it opens up or down, but the number tells us if we have a vertical stretch, if it's a whole number, by a factor of A as well. Just gonna separate those. And if we have a value between negative 1 and 1, what do we notice? Well, first off, again, positive numbers opens up, negative number opens down. Now this looks confusing, so I'm going to put this in brackets. So positive numbers mean up, negative A value means it opens down. And if it's between 1, which means it could be 0, which we don't really want, but what they mean here, it's going to be a fraction. So what if the A value is not a whole number? What if it's not 2, 3, or 4? What if it's 0.5 or 3 over 4? Well, then we don't have a vertical stretch because it's not by a whole number. When it's a fraction, we call it a vertical compression. by a factor of a. So when a is a whole number, it's a vertical stretch, and when a is a fraction, then it's a vertical compression. And the value, if it's positive or negative, just tells us if it opens upwards or downwards. So what do we mean by vertical stretch and compression? This one's probably the most difficult to visualize. So when we get to the graphing part, it'll make a bit more sense. So for the a value, this is letter A, not a 9, letter A, if this is our parent function, just so this is where the regular one, or most basic one, we'll just call that y equals x squared. What do we mean by stretch and compression? Well, stretch kind of means we're actually stretching these arrows upwards, we're pulling on them. So my graph is actually going to look thinner and more narrow. And if I'm compressing it, it's like I'm pushing down on the parabola. It's like I'm pushing these two arrows on these two sides, pushing them downwards. So my parabola would actually look wider, like this. So that's what I mean by stretch. It's going to get taller, and compressed means it's going to get wider. So we're going to see more of this in 1.5 again, but hopefully we understand the terminology of translations, like what I mean by translates. It means it shifts. Hopefully we know horizontal and vertical. And hopefully we understand this stretching and compressing based on what the a value is. So if we understand these, we're just going to practice how well do we understand the numbers and the letters and what they mean. So now we're going to look at and practice, do we understand what the letters and the numbers mean through this table. So we have our first equation in vertex form, and we have to determine the value of a, h, k. We should list the vertex as well, and we did this in our our last lesson. And then we're going to determine the number of x-intercepts, which we can decide. And then we're going to say, well, what do these letters mean? And we're going to put them into little point form sentences. And we'll get to the domain and range maybe a little bit later. So let's start with this next one then. So our a value here is -2, because that's where the a is in the vertex form equation. So a is going to be -2. H looks like it's -3. So remember though, it's going to be +3, because it's opposite of what it looks like. The k value is going to be +3. So our vertex now is just what these are here, because we already determined what h is and what k is. So it's going to be 3, 3. The number of x-intercepts. Well, we can, now that we know what the vertex is, and we kind of know if it opens up or down, maybe, you know what, let's do the transformations and maybe we can see that afterwards. So what do these letters mean again? So when we have a negative a value, we know that the graph is going to open down. Now some people also say that this is a reflection in the x-axis. And that just means it's flipped. So if it was positive, I'll draw it over here. If it was positive, a reflection in the x-axis means it's just flipped downwards. So you can say it opens down, or we have a reflection in the x-axis. This is the more proper term, but opens down means the same thing. So then that's what the negative on the a value means. The 2 means we have a vertical stretch. By a factor of 2. Sorry, 2, because our a value is 2. So I know the negative is there, but it's a vertical stretch by a factor of just the number. The negative means that the parabola opens down. Our h value, it's a +3, so we're going to have it translated. Well, how many units? Well, h is 3, so 3 units. And because the h value is positive, we're going to move to the right. The k value means we translate up or down. So we're going to translate three units, because the k value is 3. And since k is positive, plus 3 in the equation, we're going to move up or upwards. So now for the number of x-intercepts, well, we can kind of know where this vertex is. If I were to make a quick graph right here, and I'm thinking, where is 3, 3 in the vertex? Like, which quadrant would it be in? It's going to be like probably around here, about 3, 3. And I know the graph opens downwards. So I can see that my parabola is going to go through the x-axis probably twice. So I'm going to say that there's going to be 2 x-intercepts. This one's going to be a bit tough to see, but the more we do these, and the more we see that where the vertex is and how the parabola opens, we're going to see how many x-intercepts are going to be. I'll probably zoom in for the next one too. Okay, so for the next one, we have this equation here. So our a value is going to be 1 over 2, or half. There's no negative sign, so just positive 1 over 2. Our h value, it's positive in the brackets. Remember, it's opposite of that. It's going to be negative 1. And if you're wondering, well, why is it negative 1? Remember, in our equation here, x minus h squared plus k. This is our kind of our root equation. This is our basic equation here. If it was this, this must have been negative 1 for it to make it positive here. So h is negative 1. Our k value is going to be just the plus 5 here. So positive 5. Now that we have the h and the k, our vertex is negative 1, 5. We'll do the x-intercepts afterwards. Let's talk about what these letters mean. Well, the a value here is positive, so it's going to open upwards. So the parabola is going to open up. Sometimes this is kind of a given because usually, well, if we don't see the plus, we don't usually say it opens upwards, but if you want to say it opens upwards, then you can do that too. But if you forget it, you'll still get the mark. But either way, I'm going to put it anyway. So because it's positive, it opens up. Because the h value is negative 1, we're going to say it's translated. How many units? Well, 1 unit, because that's the number. And the negative just means which direction we're going. So we're going to say 1 unit to the left, because we have negative 1. Our k value is 5. So we're going to have translated 5 units, because k is 5, 5 units upwards, because we have k is a positive value. It's positive 5. And I just realized I skipped what the actual number means for the a value, but these still ring true. So the a value is a vertical, but because we have a fraction now, instead of stretch, the other word we had was compression. So vertical compression by a factor of 1 over 2, or factor of half. So vertical compression by a factor of 1 over 2. So that is what each of the letters represent. So let's talk about the number of x-intercepts, and I'm going to zoom in here. If you need to copy this out, you can just, pause the video. Have that power. Alright, so I'm going to make my graph here. And if I know where my vertex is going to be, negative 1, 5. Remember, this is an x and a y value, so I can put this on the grid here. So negative 1, 5 would maybe be like here. Let's say this is 5, this is negative 1, it's on that part of the axis, so negative 1, 5. And I know that the parabola opens up or down. Well, the a value is positive. We said that the graph opens upwards. So if the parabola opens upwards, well then this is never going to cross the x-axis. So there's going to be 0 x-intercepts, or there are no x-intercepts, there are none. So either answer is fine. So at this point forward, if you want to just pause the video and then try doing it on your own, make some guesses. This one looks a little bit different from these other ones, so maybe you want to try it out. Then you can pause it, and then I'm going to just take it up, and you'll see then. But if you want to try it on your own, feel free to do that. So our a value here is going to be 2. Our h value now. Well, remember in our equation, h is inside of these brackets, and I don't see any brackets. So here's a case where our h value is 0. Our k value is still here, though, plus a number here. So k is going to be plus or just positive 9. Our vertex is just the h and the k value for that vertex. So we said h is 0 and k is 9. So what do these letters mean then? Well, a is equal to 2, so we know that it's positive. The parabola will open upwards. 2 is a whole number, so we have a vertical stretch by a factor of 2. There is no h value, so there is no horizontal shift left or right, so we don't have to write that sentence. Our k value is plus 9, so we are going to have I wrote this a bit differently, but we're going to translate it. It's translated. It's translated. Not translated. Translated 9 units upwards because our k value is positive. So if one of our values is 0, we don't have to write a sentence for it. All of our cases of our k value have also been positive, but if this was like minus 9 or minus 5, it would be translated 9 units downwards instead. All right, one more to do. All right, so let's pick the letters here. We have a is going to be negative 3. Our h value, because we have the brackets here, h is going to be, we see positive 5, so it's going to be the opposite of that, negative 5. And I don't see a number beside the brackets, beside the squared here, so there's no, we're going to have k is equal to 0 in this case. So our h and k value are going to be this. Negative 5, 0. I see that in my haste I forgot to do these, so I will do these, afterwards after we do what the letters mean. I think this is the main part of the lesson here, understanding what the vocabulary and what these letters represent. So we have a is negative 3 now. So because it's a negative number, the parabola will open downwards. Since the a value is a whole number, we're going to have a vertical stretch. By a factor of 3. We have an h value, so we're going to have horizontal shift is what I'm kind of used to saying, but to make this simpler, we just say translated 5 units, just the value, and the positive or negative tells us if we move left or right, so 5 units left because it's a negative value. K is here, so there's no shift up or down, so we don't have to say any vertical shift up or down. So for the graph for both of these, remember what we said on our first page. So when the h value is 0, what do we notice? Well, in this case, h is equal to 0. So if I were to make a graph of this, I'll make this a bit bigger. But because we only have a vertical shift up and down from if our parent function just starts at the origin, we're just going to move upwards. So if this moves upwards and then, well, a is positive, it's going to open upwards. There's no way this parabola is going to touch the x-axis here. So there are 0 x-intercepts here. For our last one, we have this, and the k value is 0. And we said when the k value is 0, the parabola stays on the x-axis. So we're going to see when we have our vertex here, -5, 0, that's over here. So I've shifted this over, and it opens downwards because the a value is negative. So we can see that the vertex is on the x-axis there. So in this case, there's actually only one x-intercept, and that is going to be the vertex. So you can see the rest of the note is actually just some homework for you to double check. How well do you know what these letters mean? So I'd like you to fill in the blanks. We'll take it up in class later, and then some more practice here, and then even more textbook questions. So plenty to do. So thanks for your time.